In this video, we're going to take a quick look at significant digits, how to identify how many significant digits are actually in a value. Doesn't matter what you're measuring. Could be something you're measuring by volume or distance, mass, excuse me, anything at all. It doesn't really matter. So we'll take a look at when you see a value written, you can determine how many significant digits are there. We'll look at the rules dealing with zeros, how to handle zeros in numbers. And then also when you do your different functions like multiplication, division, addition, subtraction, how do you know how many numbers to write? Very often we see things in, we punch numbers into a calculator, and through middle school we're like told things like, I don't know, write everything to the nearest hundredth, and it's still common today. It was like that when I was in middle school, and I still hear a bunch of my students today tell me the exact same thing, right? So we're gonna learn once and for all exactly how to determine significant digits from our calculations in a way that's going to work every single time. Let's just jump right in. Sig figs, significant digits. What are they, and how many digits do we use, and why? Let's go ahead and let's jump in. Let's take a look at what we've got here. So here are some functions. I'm sorry, not some functions. I just finished doing a physics class. Here we have some values. Here's 6 different numbers. I just sort of grabbed these whimsically, just sort of made them up. It doesn't even matter what the unit is, gram, kilogram, centimeters, millimeters. You could put the word donuts after it for a unit. It really doesn't matter. What I want you to do is, for each of these, I want you to determine the number of significant digits in the values based off of lessons we've already had, based off the notes that I provided for you as well. Do that. Pause this video. Do that real quick, and then unpause the video, and let's check your work. Pause now. Okay. So we have 63.1 grams. So the total number of significant digits. So you have 1, 2, 3 there. There are a total of 3 significant digits in this value. Here you have 1, 2, 3, 4. There are 4 significant digits in this number. And I've had people get confused. This is a classic thing that confuses people. I've had people say that this one only has 3 because they'll sort of ask me or just sort of say, hey, aren't zeros are not significant, correct? Well, in this case, the 0 is significant, and the reason for that is if it wasn't significant, then you would be saying 7.41, and that's a completely different value. Imagine you had money. If you had $7.401 versus 7.41 because you left that 0 out. Now I know that's only a difference of 1 penny. I know it seems like that's not much, but if a million people purchase something that is $7.41, those pennies begin to add up. And so you can see that this 0 is significant right here because it pushes this other number off to the side. Okay. So right here, if you think about this, if you cover up all of this, and you were just to look at 0.0, you still have nothing. If you still have 0.0, you still have no value. And then all of a sudden, the very first significant digit that shows up is a 1. So there's your first significant digit. And then there's your second significant digit. So this one has a total of 2 sig figs. So the same holds true for here. There's no significant digits until you get to that 1 there. So that's 1, 2, 3, 4 significant digits. This is 1, 2, 3. And this is 1, 2, 3 as well. And again, the rule here works just like it did up here. Okay? Take a moment here and answer these 4 right here. Determine the significant digits. Go ahead and pause now. All right, let's see what you've got. there's one significant digit, and every one of these zeros is significant. So zeros that once you have one significant digit, I don't care what the number is, every zero afterwards is going to be significant. And the reason for that is this, is if you said these zeros were not, then you would just have a value of 3.5, and that's a whole lot different. Again, if you were talking about money, 3.5 versus 3.00, was there 4 zeros there? 005 dollars. This is the same as $3.50. So you can see that there's some significance there, right? So that's important on that. Now you've got 1, 2, 3, 4, 5, 6 significant digits. All right, now right here, let's skip this one and this one. Let's go down to here. So, and the reason why, you'll notice that every number we've had so far has a decimal in it, and these two do not. So these are going to be very important. Right here, 0.9. Again, nothing here. If you just say 0, and you have 0.9, so there's only one significant digit in this value here. Okay. All right, so now let's take a look at this, 6 meters. So it doesn't matter what the unit is, all right? I'm scratching through the unit for a second just to let you know, it does not make a difference what the unit is. It does not make a difference. So this number here, the number 6, the correct answer for this is 1 or infinite. The answer for this one is 2 or infinite. All right. And so now let's think about this for a second. Let's think about this for a second. Why is it infinite? I mean, that means it can the number can keep going and going and going and going and going. All right. So let's use this one as an example first. I'm going to just do some work over here. So we've got the number 6. Well, that's one number. So if I had 6 with a decimal, and that's it, I would say this is 1 or infinite, and I would say this is 1. I would not say infinite. This right here is 1. This is 1 or infinite. And the difference is that decimal. When you have a decimal, you have a measured value. A tool was used to measure it, and then some sort of calculation was done that got that value. That's what decimals do. The decimals go back to that concept of precision. So here's a way to put that in perspective, okay? I'm going to leave this 6 here, which is 1 or infinite, and this 6 with the decimal. Now if I add a 0 here, it changes the value of this number to 60. If I add a 0 here, this is still the value of 6. This is now 60. So you can see that 1 or infinite is beginning to make sense, because I can add another 0, and now the value of this is 600. But if I add another 0 to this one, this is still a value of 6. It has not changed. So when there's a decimal, it becomes fixed. But I can infinitely add zeros to this top one. I can infinitely add zeros, and the value continues to increase, which is why we say 1 or infinite. When there's no decimal, it's always going to be however many digits are there, and then infinite. Once there's a decimal, you're counting, well, you're finding the very first number that's not a 0, and then every number after that is also significant. So with that said, let's take a look at this, at the number 48. All right, if we take a look at 48, I'm just getting that out of my way. Okay, we take a look at 48, then we go back to the concept of 48 point. We would say right here, we would say that this is 2 or infinite, which we already said, right? That's a pretty bad infinite sign. Let me try that again. Not much better. We're going with that one. This right here we say is 2 significant digits. If I add a 0 to this, the value of this becomes 480. If I add a 0 to this, the value of this is still 48. This now has 3 sig figs, but the value is 48. Just like up here, this is still a value of 6, but it had this number right here, 6.00, that has 3 significant digits. If I were to add another one to this one, that's 4 significant digits. 1, 2, 3, 4. But it's still a value of 6. Come back down to this problem. If I add another 0, I'm infinitely increasing the value of this number. It's now 4,800. If I add a 0 to this, this is still a value of 48, and so on and so on. So this right here infinitely increases in value. This right here only increases the number of significant digits. Okay? So now let's put this to practice. Do these 4 problems, calculate these 4 problems, and then report your answers with the correct number of significant digits. Go ahead and pause the video now. Okay. Let's work on this. So I don't know. I just made these numbers up. So we got 3.00005. Correct? 4 zeros? Yes. That's times 18.2. So that is, in the calculator we see 54.60091. All right, so the question is how let's actually do this. I'm just going to do all of the math real quick, okay? I'm just going to do all the math real quick and get that out of the way. 6.00, this is divided by 14.5. All right, in the calculator we see 0.413 793.103. Now, if you have less or more numbers, it just means your calculator is set to display less or more digits. But you should have basically this value here. So we got 48. This is plus 111.25. And that gives us 159.25, right? Yes. And then we have 0.9 minus 0.539. That gives us a value of 0.361. Okay, so now that we've got our math done, let's go ahead and let's figure this out. The rules for multiplication and division are the same, and the rules for addition and subtraction are the same. When you multiply and divide, the final answer should have the least sig figs of the numbers measured. What that means is in class, you're always going to have a number that'll have a unit after it, like centimeters or meters or grams or milliliters or something. So we think of each of these as a measured value. So this answer here, this number here, 3.00005, has 1, 2, 3, 4, 5, 6 significant digits, and this number here has 3. 3 is the least sig figs of those that are measured, so we want 3 in the final answer. All right, we want 3 in the final answer. Oh, I'll just leave it purple. I like purple. So there's 1, there's 2, there's 3. All right, the third significant digit gets us to right there. There's 3 significant digits. And then we take a look and we realize, we look at this 0, and zeros will not round up. So that means the final answer for this is 54.6. That is the final answer right there. So let's just say that you were in class, you were using this value and this value. I would expect to see that you write all of this, every bit of this, and then I expect to see that you know that you report the final answer as 54.6 because that has 3 significant digits. All right, let's go to the next one. 6.00 divided by 14.5. This has 3 sig figs and that number has 3 sig figs. So you want 3 sig figs. All right, well that 0 right here, not significant yet. There's your first 3 significant digits right there. There's your first 3 significant digits. All right. So this 7, whenever you have extra numbers, you take a look at the very next value. That 7 would round that 3 up, so the final answer would be 0.414. This answer has 3 sig figs, which matches all of that right there. Okay. Addition and subtraction. You want the least sig figs, and I should say the least number of sig figs after the decimal. Okay, after the decimal. So let's think about this. When we add and subtract, you're only looking at the total number after the decimal. Well, this has 1 and this has 2 after the decimal. 1 is less than 2, so we want 1 digit after the decimal. This 5 could round that up, so 159.3. That's the final answer for this problem. Okay, and then this one, 1 significant digit after the decimal, 1, 2, 3. 1 is less than 3, so we only want 1 after the decimal. This 6 would round that up, so the final answer should be 0.4. And there's your final answer for that last one. Okay? And those rules are never, ever, 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 ever going to change. It'll always be that way. Okay? Real quick, let's pretend that this last problem was and I'm making this up, 0.97 minus 0.539. I'm making this up, right? Okay, so punch into your calculator, 0.97 minus 0.539. That gets us an answer that is 0.431. Okay, so now we look at this and there's 1, 2 significant digits, and here there's 1, 2, 3 significant digits after the decimal. So in a situation like this, there's your 2 significant digits after the decimal. We can see this 1 would not round up that 3, so the final answer would be 0.43. Okay. This should shed a lot of light on how to use significant digits. Definitely review the work and be ready to show that you understand this with lab work and any assessments that we have. Check back. It was good seeing you. Good talking with you. Bye. And there you go. It's not too difficult of a task. It's pretty easy actually. Just repetition is what helps. You're not used to doing this. Well, you sort of are and you aren't. So you're used to doing things where you sort of understand concepts without actively thinking this is a significant digit. So it's just like examples that you see everywhere in life, like with gasoline. You know, no one really pays attention to that tiny little 9 that's up there, but it's significant because if they didn't have that 9 there, there would actually be they would have a lot less profit, and they already have an excessive amount of profit as it is. So we tend to look at the price of gas and might see $2.79 a gallon, and we go, wow, I'm only paying $2.79, but as we know from the video, you're not. You're really paying $2.7999 per gallon. So those things add up. It's significant because over time, with enough of that, it adds up some big money. So significant digits is pretty easy. So and everything we're going to be doing in class, all your lab work, calculations, things like that, you will be responsible for making sure you understand from your work how to report your significant digits properly so that the correct value is written. What trips people up the most is whether or not you have to add zeros or not add zeros, when to add zeros. And so from some of the stuff that I showed you, hopefully that's evident. But with work we're going to be doing in lab and extra videos that I'll be making with stuff, you'll get it. You'll be fine. So it was good seeing you. We'll see you in the next video real soon. Take care. Bye.